Alright, just a quick extension to FreeCircuitLabs' very good video on how to modify a cheap buck converter to add a basic MPPT, non-tracked MPPT adjustment, which is quite useful for solar panels. So his one was a lower unit, I think it was about 5 or 6 amps. This one is 25 amps, so it's a bit more. I bought it cheap on eBay. This is the item here. There's a lot of fairly similar ones. This one I liked because it actually had a display for the current and voltage, and it was a bit cheaper when I bought it. It's gone up a bit now, and it seemed to work. When I arrived, I quickly plugged it in and checked that there was some output. I didn't do a thorough test. I have to let you know. Basically, firstly, this piggyback PCB has to come off. Just desolder a few pins, and then I'm probably going to put like a header on here to plug it back in, so I don't have to do this again. And then this is the comparator that's involved in making the current limiting feedback. So there's a track that connects pin 3 and 6 underneath that, and obviously they need to they're two comparators, so need to basically cut the track on the PCB and adjust some of those resistors. Okay, so we're all done now. I put a couple of permanent headers on there, so you can just unplug the meter board when you need to. I've added the MPPT adjustment pot here next to the input terminals. Sort of desoldered and as I said before, and cut the track under this comparator and linked up to the appropriate tracks. Change some of the resistor values, some of the reference values for both sides of the comparator. This pot adjusts the voltage, this one adjusts the current, and they both still work. There's no 2.5 volt reference, as I said before, on this circuit. That's your main control chip for the switch mode pulse width control. One of these is power for these chips. Well, that little thing there is the 5 volt regulator. Okay, so that's your high and low side MOSFET, and these are two Schottky diodes, which are quite useful, so you don't have to worry about reversing the output. On the back, just a little bit of connection to the input, and it goes through the board there. So now I've got it connected to the battery here. It's off at the moment. I've got a meter on the input voltage, and I'm just about to switch it on or apply power at 50 volts or around about 50 volts. And if I plug it in, the output has gone to 12.3 volts, which is the state of charge of this battery, at 2 amps, and that's the most that this power supply is capable of supplying. And you can see that the input voltage has dropped from the 50 volts over there to 18.9. So that can be adjusted now with this like MPPT pot here. You can set the input voltage to whatever value you want. So if you can see now I'm just turning it. So you can, if I adjust the current limit on this power supply down, so it can only supply less, power. You'll see that the output current will fall. That the input voltage won't change, it's going to stay at 19 volts. And as you can see, look, I'm turning the knob down. If I go onto the current setting, as I adjust that current down, at the moment it's over an amp, and it's like the output is at 1.5. It was higher than that. It's falling, okay, because obviously I'm reducing the input current, and the MPPT voltage, the input voltage, is staying at 19 volts. As I reduce the current, again it like still keeps this at 19 volts, and the current is still dropping. It's dropping as I'm adjusting it down, so you can see basically it goes with the current. And it's still 90 volts. So if I go back up, then it will come back to the maximum that this particular power supply is capable of supplying. And it's unfortunately still limiting even on the maximum output of this power supply. But that's basically the demonstration that the MPPT function does work. It's quite steady with a battery connected to the output, which is what will normally this will be used for. If you connect a bulb to the output instead of a battery, then it tends to flicker quite a lot, because there's quite a lot of instability between the competing control of the output voltage and the MPPT voltage. It's the output regulation and the input regulation is kind of fighting against each other, and you've got this parasitic kind of feedback. It's not a problem with the battery connected, but I mean, which is what you'll be probably using it for most of the time with solar panels anyway. I mean, it's I think you could try and smooth that out perhaps with some more effort, but I think that's an inherent problem of trying to sort of have dual control over one switching regulator. In terms of the efficiency, it doesn't really change the overall efficiency of the device much. I haven't really found out. I can't really do an accurate measurement. That looks like about 6.3 watts according to that meter there. And here, I mean, it's actually, since that's at 19 times 0.3 amps, that's actually showing lower power at the input, which obviously doesn't make sense. So something doesn't make sense, but it can't be lower power going on the input. But it just goes to show that this is still showing like probably like at least 90 or 94% efficient, which is pretty good, pretty typical for these things.